Welcome everyone to this evening seminar. My name is Jen Cardwell. I'm one of the CIBSE committee members based in Brisbane. Before I hand over to Vance, I'm just going to run through a couple of CIBSE slides quickly. First of all, we'd like to acknowledge the tradition throughout Australia and recognise their continuing connection to land, waters and culture. We pay to elders past, present and emerging. CIBSE ANZ is very pleased to announce the finalists for the Young Engineers Awards 2020, and we'd like to invite you to celebrate the student, graduate and young engineer finalists at an online award ceremony taking place next Tuesday. We will announce the winner of each category and share the winning video submissions at this event. We will also be joined by Dr. Kate Meyer from the Planetary Accounting Network, who will deliver a short presentation titled Building Within Planetary Boundaries. This event is free to attend and offers 1 hour of CIBSE CPD. We hope you'll join us. The very next day, next Wednesday, we have the 2020 Vision for a 2030 Reality event, which will bring experts from both sides of the Tasman to share exemplar case studies of regenerative and net zero building practices, as well as new information on future policy changes that building owners and services engineers need to understand to minimise future risks to assets, both existing and new. This event offers up to 8 hours of CPD, and with your event loyalty offer promo code, you can save $120 on a ticket. Okay, I'm going to hand over to Vance now.
Thank you, Jen. I'm just going to share my screen. Won't be a second, and then we can get started. Right. Okay. Here we go. Just need to move a couple of things around. Right, and then we can get moving. I just want to welcome everybody again and thank you for your time. Holyoake Industries is a company I work for. I've been serving the HVAC industry for 67 years. Interestingly, none of the contractors we started with are still in business today. Our commitment to the fire damper program is immense, actually. We've built a fully functioning test furnace at our Auckland facility. Complete with full live sensing data, and that allows us to future-proof and back up all of the design options with test data prior to going to third-party development. That allows live testing throughout the entire program, and we've learned a considerable amount over the last 5-year period that we've had that facility going, which allows us to pass some of that information on to industry today. Just before I move forward, there's a lot of information to get through, so I'm going to get through it quite quickly. I've only got 30 minutes, and I do apologise for the speed of some of the stuff that we need to travel through. But if there are any questions, Q&A questions, if you can fill them out on the Q&A button, and Peter Lang will have a look at those at the end of the session, and we'll endeavour to get through as many as we can. Right, just okay. Just very quickly, I've put some information up on some of these slides that I'm going to really skip through, but it's there for people afterwards, and it covers some of the terms that we're looking at. So I've got some information there on FRL. I would assume that most people understand what that is, so we'll skip through that and leave that for anybody that wants to look at it afterwards. We're going to cover just some of the fire dampers that are available in the marketplace and smoke dampers right now in Australia, and some of the definitions around those. What you see on your screen now is a mechanical fire damper. That's a thermally activated device via a fusible link. Now, fire dampers are tested to AS 1530.4. Section 10 is for perimeter seals and air transfer assemblies. And Section 11 is for ducted assemblies. The current testing standard is AS 1530.4, 2014. Mechanical fire dampers typically activate at temperatures around 71 degrees C. Ours activate at 71, bullets, for example, activate at 77. So they're all very, very close to that activation temperature. And typically a steel mechanical fire damper will have an FRL of -240-, therefore it has no insulation value. Fire dampers are available in vertical and horizontal orientations. Horizontal fire dampers are required to be tested in their own right. That's listed under clause 2.9.7 and AS 1530.4. Horizontal fire dampers also must have a latching system within the damper itself so that they don't bounce back upon closure. And it's absolutely critical that people understand the correct orientation to install a horizontal fire damper, as most of them will latch from one side only. Multi-section dampers are definitely something we wanted to cover in a little bit of detail. You'll see there the graphic. That's actually a 2400 by 2400 damper in a test wall down at Warrington's a couple of years ago. And you'll see there that there's a mullion system holding the dampers together. Now, typically prior to 2005, multi-section dampers were actually screwed or bolted together to make up the various ducting sizes that were required. And then installed in the penetration. In fact, that's no longer an acceptable practice. We've found in subsequent testing that when you bolt a series of dampers together on the sleeves, that the sleeve areas open up, and that allows transfer of fire and products of combustion through those apertures. So multi-section dampers, like all new fire dampers, now need to be tested in their own right. And it's absolutely critical that people understand this. I will cover the grandfather clause in a little bit more detail as we go further forward, which currently means that it's acceptable practice to screw fire dampers together, providing you've got a test report that covers that type of installation. I've also got there that AS 1530.4 clause 11.4.7 states the minimum separation between dampers is 200 millimeters when tested. Smoke dampers, these have caused quite a lot of contention actually since about 2015. They're required to be tested and certified to AS 1530.7, 2007. And it's absolutely critical that people understand that. A lot of the fire/smoke dampers that are in the marketplace today were actually only tested as a fire damper. So they were tested to AS 1530.4, often the 1990 version of that, because at that time there was not a separate definition for a smoke damper. And interestingly, the grandfather clause in the NCC does not cover smoke dampers. So the smoke dampers that are going into buildings right now really do need to be tested and certified to AS 1530.7, 2007. And it's critical that people understand that definition. Now, they've got to be capable of operating at elevated temperatures. There are two primary temperatures that are used in the testing standard. That's 200 degrees Celsius for buildings protected by a fire sprinkler system, or 300 degrees Celsius for buildings unprotected by a fire sprinkler system. Interestingly, AS 1530.7 does not have specific criteria for passing or failing that test. And the reason I bring that up is I had a consulting engineer put a report in front of me some time ago for a smoke damper, and the dampers in that report actually would have failed the test. And in fact, the testing authority that tested those dampers was not NATA certified to test smoke dampers. So again, it's quite critical that people understand the level of detail in these reports and follow those through. A little bit on intumescent dampers. Intumescent dampers activate at temperatures above 180 degrees Celsius. All of the testing I've done with intumescent dampers would lead me to believe that you've got to have an even temperature across the face of the intumescent damper. So if we get stratification in the duct, which often happens in that situation, you'll find that the damper will partially close, which obviously is quite a problem. We actually have a test rig at our facility here in Queensland that we can show people both mechanical and intermission dampers in operation. Actually, I'll rephrase that. It's a demonstration rig, not a test rig. All right. Some mechanical dampers now have intermission materials. In fact, our range of fire dampers has an intermission seal on the mounting angle. Combined fire and smoke dampers. Again, I really can't harp on this point enough, because I do see a lot of errors in this area of our industry. They need to be compliant to two standards. So that's AS 1530.4 for fire and AS 1530.7, 2007 for smoke. I see that there's an error in my slide there. We will get that sorted out. I do apologise for that. So a combined fire smoke damper assembly, right, must be compliant with those two testing standards, right? And it is possible to use a fire damper and a separate smoke damper to achieve a fire smoke damper assembly. Air control dampers, these do cause a bit of an issue in the industry. It's common practice for designers to use the combustibility and temperature of fusion clause in AS 1668.2 when specifying air control dampers. And generally, quite often, particularly in the Melbourne region, we see them specified with a fusion temperature of 1000 degrees C. In that case, we tend to find that steel dampers are used. The interesting thing about steel dampers is that they do tend to leak more than aluminium dampers. It's much harder with the structure of the damper itself to get an effective seal in a steel damper, particularly at low temperature. You'll find that steel gets quite pliable quite quickly. And because the dampers are supported from axles at either end, you'll find that a large part of the damper blade is actually unsupported when it's in use. I tend to push people towards aluminium dampers where possible. We find that we get a better seal with the aluminium damper. And one of the things about air control dampers, or air dampers / smoke exhaust, as they're defined in 1682, is that the role is obviously to exhaust smoke, but for most of their life, they're there to ensure that we don't get a lot of leakage through those dampers, so that we can keep the energy efficiency up within the system, assuming that it's a dual purpose duct. And we are often seeing dual purpose shafts now and dual purpose ducts in designs around Australia. Now, air dampers for smoke exhaust are actually listed under the performance requirements in 1682 as being required to withstand a temperature for 2 hours. So that temperature being either 200 degrees C for a sprinkler controlled building or 300 degrees C for a non-sprinkler controlled building. The interesting issue with that statement in 1682 is that there is not an Australian standard test for that criteria. So as a manufacturer, when you take your damper to the Registered Testing Authority, we cannot get a certification to an Australian standard because there is not a testing procedure or procedural standard in existence in Australia currently. A little bit about installation. I'm not really going to, again, spend too much time on that, just with the audience that we're talking about today. But a couple of things to think about, particularly when we're specifying dampers. Obviously, smoke dampers can now be installed up to 600 millimeters away from the smoke damper. It's critical that manufacturers' labels and installers' labels are fixed to fire and smoke dampers. Another point I'd make is breakaway joints should not solely rely on high temperatures to fail. In actual fact, the tensile strength of a good nylon bolt is phenomenal. I don't know how many people have done this, but I challenge all of the engineers, in particular listening to this, to take a nylon bolt, put it in a vise, and then bend it round and really truly understand that tensile strength. Now, I was unfortunate to be in London when there were bombs going off a number of years ago, and I can tell you that structures come down sometimes in a situation for not the reason that you think. And I guess what I'm trying to get to is that we want to maintain fire barriers and smoke barriers. So we need to understand that we're not always trying to maintain that in those barriers in a fire situation. It could be an earthquake, for example. We have a number of those in New Zealand, right? It could be an explosion of some sort that's causing other parts of the structure to come down and fail. And we need to really think about that breakaway joint and make sure that that breakaway joint's going to break away in that sort of situation. For those of you who know me, this is almost a mantra for me: always test fire dampers after installation. I've had some very embarrassing times with fire dampers from time to time being racked in trucks and racked during installation. And it's not always easy to tell whether there's been damage to a fire damper or a fire damper sleeve before you install it. A little bit of information on the NCC and standards. There's a number of standards that we have to draw our information from. A lot of those standards committees are not communicating as well as we would like. And some of those standards cross barriers that perhaps you would think that they really shouldn't cross. So it's really difficult to get all of that information and ensure that you've got consistency of that information all the way through. So it's quite a minefield trying to get to the bottom of all of this information. Quick slide on how compliance works generally in our situation. Certainly using the deemed to satisfy route. We've got the Australian Building Code, the NCC, which refers to 1668.1, 2015, which then refers to 1682.1 and 1682.2, being the specification and installation of fire, smoke and air dampers. Those standards refer to AS 1530.4, 2014, for the fire resistant tests for elements of construction, and 1530.7 for smoke control assemblies. A little bit again on 1530.7. 1530.7 really came out of smoke doors. So it wasn't written for smoke dampers, which is why you'll see so many inconsistencies across that standard. Its heritage is in a totally different place. Just covering that deemed to satisfy route. We talk about compliance with A2.1 being the performance requirements that are laid out in the NCC. And then we go through to A2.3, which is a deemed to satisfy solution. And then obviously we follow right through the standards that I've just listed there. And ultimately that ends up in a test report. Generally the industry will see that as an RIR report. Right, just moving forward. Performance solutions are a combination of deemed to satisfy solutions. Now, there are some anomalies out in the industry at the moment. So there's quite an issue coming, particularly out of the FPA, when we talk about who can determine an FRL. And that really is quite a sticky question. I know at some of the committee meetings I've been to, we've spent several hours talking about that sort of thing, and it can cause quite a headache within the industry. But from what I can tell, it's very clear in 407.2.1, clause 4.2, and that states a formal opinion shall include the name of the RTA, the Registered Testing Authority. All right. So determinations about FRL or alterations in fire dampers or alterations to installations of fire dampers really need to be determined by an RTA as opposed to a fire engineer. Now, there are other routes to compliance. I'm not going to cover those today. They're quite complex and really I'd need a lot more time than what I've got this afternoon to cover those. But I think the key thing to really understand is that when we start to talk about an appropriately qualified person to form an opinion of the validity of a fire damper in an installation that's different to what was tested, it really should be done by an RTA. Quickly covering the grandfather clause. The grandfather clause exists in the NCC, and it states until May 2022, subject to the note in 407.2.1, reports relating to tests carried out under earlier editions of AS 1530 parts 1 to 4 remain valid. Excuse me. Sorry. Right. It is quite interesting to understand that if we manufactured or developed a new fire damper, we couldn't refer to that clause. We'd have to test that new fire damper to the current standard. The grandfather clause also only exists for fire dampers. It does not exist for smoke dampers. Obviously, that's AS 1530.7. A little bit of information on the standards there. I'm actually going to rush through that and let everybody have a little read through that afterwards. But I would draw your attention to AS 1682.1 and the performance requirements for fire dampers and smoke dampers and fire smoke dampers. Also, air control dampers are listed in that standard. Now, a couple of quick graphics up there of testing. Not a lot of people get to see this. I'm one of the lucky people that get to play around with very hot things and spend time at testing authorities. The graphic at the top on the left is the furnace that sits in Warrington's. On the right-hand side at the top, there we are testing. You can see 4 hours, 45 minutes, in fact, a smoke damper and a smoke wall. The graphic down the bottom on the left, that was a multi-section damper test, and in fact, we were testing the mullion for fire dampers at that point. That was at about just over 1,000 degrees, about 3.5 hours into the test. It was pretty warm, I might add. The one in the middle down the bottom is that multi-section damper with the mullion in it. The graphic on the right is actually a circular fire damper in the test wall after it had been removed from the testing furnace. And obviously we were having a look at the damper and how it looks on the back. I can tell you that looking at some of the gyprock that comes out of those furnaces, it really does blow your mind in terms of how good some of those products are out there. Just want to push again the difference between Section 10 and Section 11. Now, there's a lot of claims made by manufacturers out in the marketplace that they're compliant with AS 1530.4. We need to be very clear about what part of AS 1530.4 we're compliant with. All right. Section 11 is for ducted assemblies. So if we've got duct connected to one side or both sides of the fire damper, it must be tested under Section 11 because Section 11 utilises the 300 Pascal pressure differential test and that proves the integrity of the fire damper. Section 10 is a perimeter seal test. So it's only testing pretty much the outside seal of the fire damper against the fire barrier. So I want to spend a bit of time on this. This is the route to compliance particularly from a manufacturer's point of view. A lot of people really don't understand this too well. So as the manufacturer, we develop a product. We spend quite a lot of time with engineering and design, in-house testing. All right, to try and make this work. And we have to work with installers, builders, certifiers, end user clients, designers, regulators, and with so many different people involved, everybody has a slightly different requirement or performance requirement, and it can be quite a minefield trying to get that right. So I want to hopefully I can sort of put a few of the myths to bed. So let's start with AS 1530.4 evidentiary compliance, right? So the minimum evidentiary compliance document is an RIR report. It's a regulatory information report. Now, interestingly, the RTAs can't agree on this in terms of the name of that report. For example, you've got one RTA that will only write an RIR report based on a fire damper test. You've got another RTA that will write an RIR report based on an assessment. Now, I just want to cover how that works. As a manufacturer, when we develop a new product, obviously we want to try it in lots of different wall substrates. We want to put it in vertical situations and horizontal situations, and we want it to cover a range of different installation situations, speed panel, drywall, Hebel, concrete walls, and floors for that matter. So we've got to go through a range of different testing options. Now, what typically happens is we'll spend some time with the RTA, the testing authority, and they'll write down a testing program so that we can test all of these aspects of these fire dampers and smoke dampers for that matter, and all sorts of different orientations. So generally the way this works is usually we'll do a section 11 test for a vertical, and we'll do a section 11 test for a horizontal. So we're taking care of the 300 Pascal pressure differential test, and that's for the entirety of the test. Usually we'll do that in a concrete wall or a concrete floor slab, and the reason for that is we want to prove that integrity for 4 hours, which is the maximum that we tested here in Australia. And then after that, what we'll tend to do is a number of section 10 tests. So we want to make sure that the fire damper performance will be the same in a gyprock wall, for example, or a speed panel wall, or recently we tested one in a wooden floor, actually, for that matter. And we want to make sure that the perimeter seal will stay intact and that the fire damper won't radiate too much heat through its case or cause any other problems. So we'll run through a series of those tests. And they all have different values and slightly different requirements. So we might have 8 or 9 different test reports for a particular fire damper. And of course, the industry wouldn't be able to decipher the information in all of those reports. And in fact, if we tested in this particular type of concrete or Hebel panel, nobody else could use that data out in the industry based on that particular test report. So what we do is we take that range of tests, we work together with the RTA, and then they write us what's called a full assessment report. And that covers all of that test data, all of those different wall and floor substrates, so that we've got all of that information in a way that people can decipher it and read it and understand it, and we've got it all in the one place. We then condense that report down into an RIR report, or those some RTAs will now call that a short form assessment report, and that meets the requirements that are listed in AS 1530.4 as the minimum evidentiary requirements for fire testing. And that's kind of how it works. But it does take a great number of those test reports to produce an assessment report. And we often will end up in a situation with a certifier or a builder where they're insistent on seeing a test report. And the few times that I've had a builder out and we've put a test report in front of them or a certifier in front of them, and no disrespect to them, they haven't really understood what it is that they've read. If we go back to AS 1530.7, for example, a test report under AS 1530.7 gives you a series of results. But if you read those results, you don't know whether the damper is passed or failed at that point. You need to understand a little bit more of the picture to determine whether there's a pass or a failure on that particular product. All right. So that's why we tend to condense that information into an assessment report, and then further condense that into an RIR report to get rid of all of that confusion and give it a definitive document to the industry so that they know that that particular product is compliant. But it is quite a process. I've recently finished some testing down at CIBSE. We did that about 14 months ago, and we're still ironing out the details in the report. So, it's a huge undertaking. It takes a long time. There's a lot of work that goes into it in order to determine compliance. So there's a couple of graphics up there. Again, just on the route to compliance, we develop a product. We then go and work with an RTA to discuss the approvals required. So we go to industry to ask for that first. And then the RTA sets the testing regime. We complete the tests, and then we run through a series of test reports, an assessment report, and then finally an RIR report. It's quite a lot, quite a big mouthful that, so I do apologise for perhaps harking on that quite a bit. But I see a number of people in the industry that are often hoodwinked by reports that purport to pass or to adhere to a standard and often don't. And it's really important that people understand how to read an RIR report or a short form assessment report. There's a graphic of one of our recent ones there on the lower right hand side of that slide. But just to recap, AS 1530.4 section 10 is for perimeter seals only. There's a number of products out there in the marketplace that purport compliance with AS 1530.4, but when you drill down through the detail, you find they're only compliant with section 10, and I've seen them connected to ductwork. So that's a real trap out there. Section 11 is the full test, which includes the 300 Pascal pressure differential test. Right, it's the RTA that schedules the horizontal and vertical section 11 test, and then a range of section tests tend to follow. All right. If the test specimen is asymmetrical, it needs to be tested from both directions, or it needs to have an arrow so that people understand the direction of airflow within the report itself. All right. Again, I've got a slide just encompassing that, and hopefully that makes it a little bit easier to see. I've got in there 2.16.3, which is the information on the regulatory information report. All right. So just to recap all of this as we head towards the end, assessment reports are based on test report data. All right, and they are really the most valid document for industry. Because they encompass all of the test data and put it into a format that people can understand. So all of the data tends to be in one report. So if you look at one of our assessment reports, you'll find that it refers to a large number of test reports. And of course, it's the RTA that verify all of those. Not all RTAs are registered for particularly smoke testing. I would advise people when they're looking at reports, particularly from obscure places, that they check the NADA website. As I said to you before, I've seen reports put out there as evidence of compliance, particularly for smoke dampers recently. And then when you actually look at the testing authority that did it, they weren't certified to perform the test. All right. There's actually no RIR requirement for AS 1530.7, so that's the smoke damper testing standard. So that does make it really difficult for industry, because there's no requirement to record a pass or a fail in AS 1530.7. All right. That requirement is listed in the performance requirements that sit in AS 1682.1, and in particular, you really want to be looking at table 2.4. All right. There is an expiry date on assessment reports. It pays to pay attention to those. Somebody gave me one a while ago, and it was one of our old reports with somebody else's name on it. So, so we do see a bit of that going out there. It is a bit unfortunate, but it does pay to pay attention to that sort of detail. The actual installation details are always in the RIR report. So you'll see the graphic there that I've got on the top right-hand side of that slide. That is actually a graphic out of the report, and that is in the RIR report. Now, I'm not going to go through this slide in its entirety, but it's there for people to read afterwards, because what I've done is I've taken the section that lists all of the critical data that needs to be in an RIR report. So if you follow this roadmap, when you're reading your reports, you'll know whether they're a relevant report or not a relevant report. And that's on these next two slides. All right. Now, just very quickly, just finishing up, third-party reports. So, so there's one out there, for example, from Speed Panel that's got ours and a number of other manufacturers' material in it. If you read through that report, even though it uses the term duct connected to penetrations, you'll find that when you look at the detail of that report, all it does is assess the perimeter seal in a Speed Panel wall. So if you were to check the validity of a fire damper, for example, in that Speed Panel wall, you actually need our report as well off the back of that, so that you can assess whether the fire damper was tested to section 11 or not tested to section 11, because that particular Speed Panel report is really only dealing with a section 10 test on the perimeter seal. Please ensure the report is current. The dates are on there. Again, that's absolutely critical. Check the installation detail of the wall or floor substrate. Make sure it matches the detail in the RIR report. There's a shaft wall system out there, for example, that is non-load bearing. So when you put a penetration through it, if you want to put a fire damper in there, you've got to support it in other ways. You can't support it in the shaft wall system. I've been talking to CSR about that more recently. So again, that detail is absolutely critical. Ensure accommodation dampers are certified to AS 1530.7. Please follow the manufacturer's installation details, right? And ensure that the DTS report is written by an accredited RTA. And finally, Section J. J5.4E requires fire dampers to not exceed a pressure drop of 15 pascals when open. Again, I think it's something that we all need to pay attention to out there in industry. So it's certainly something that we should be understanding. Now, I do hope I've at least covered enough holistically of the subject. I'm happy to talk to people about this in any further detail. My contact details are there. I take calls all day, every day, pretty much from people right over Australia with certification and design issues and that sort of thing. So happy to help in any way I can. Please don't hesitate to either contact CIBSE or myself if you would like me to or like to talk to me in any further detail. Now, Peter, I'm going to stop the share now. Hopefully, we may have seen some questions come through. If so, I'll pass back to you so that you can have a look at them and then we can go through them.
Okay, yeah, we've only got 2 questions at the moment, but I've got a couple to add. Thanks very much for that, Vance. I'm sure there's a lot more questions at the moment than we are seeing up on the screen. But let's start off. We got a very early question from Ramin, and his question was, can you see the question anyway, Vince?
I need to get it up.
I can call it up, that's fine. So fire dampers can just achieve an FRL of walls with respect to integrity, not insulation. Okay, AS 1668.1 section 3231 asked about 2 meters of duct length to achieve insulation required of the FRL of a building element. Do we need to achieve the required FRL in respect to insulation for an external wall?
Well, the standard requires us to always achieve the FRL, but the part of the standard that you've referred to, Ramin, is actually a concession to meeting the insulation value. And in fact, if you read through that, you'll find that the 2 meter duct is a non-insulated duct that you can put in there to not achieve the FRL of the wall, but to minimise the potential for products of combustion coming into contact with a glowing red fire damper. And that's really what it's all about. As far as I understand it, yes, you would need to achieve the insulation value of the external wall. There are some intumescent dampers, for example, that will meet some insulation criteria for short periods of time. But again, make sure that you read the report, because sometimes that's the sealant on the outside and not the damper itself. And there are other ways of resolving that problem. So we've recently done some testing on putting barriers around the external edge of fire dampers and fire damper sleeves to meet the insulation value. I'm hoping to be able to come back to CIBSE and a number of other people in the industry within the next month, actually, with some data on that, which I think will solve a massive problem within the industry. Originally, fire dampers weren't required to meet the insulation value of walls. The Standards Committee will tell you something different. But throughout the rest of the world, the fire damper is only there to protect the penetration, not become the wall. hopefully that's answered your question.
Okay. If we can get a little bit of feedback, Ramin, if that's answered your question. The next question came on as a chat, and Afroz Awan has asked the question, in a corrosive environment such as pools, can we recommend a fire damper and a smoke damper that is suitably constructed for those applications?
Yes, we can. I'm trying not to be too Holyoke centric, so if you can send me an email, we'll send you a model number. But we produce a stainless steel damper for that sort of corrosive environment. And what I've done in the past is we've anodized aluminium dampers to 25 microns for those sorts of environments as well. And we use an acetyl material for all the bearings. So yep. Again, I don't want to get too Holyoke centric here this afternoon. I'm not here for that necessarily that reason. But yes, there are products that we can provide that will deal with that.
Okay. Again, if Afroz, you can just confirm that that's answered your question, that'd be good. And just on your chat, please. Now we've got Dennis has asked a question. For a site installation, does the 200mm separation, does the 200mm separation applicable, noting that the 200mm separation is for testing and doesn't specify the host wall?
Yeah, you're quite right. So recently we tested a circular damper, and in that RIR report you'll see that you can have a 70mm gap in between two penetrations with that particular damper. The whole point around the 200mm was a structural point. There was concern originally, as I understand it, within the committee that the wall or the fire barrier would retain its integrity. So that's what that 200mm was originally about. In fact, you'll see in the standard that penetration, for example, should be no closer than 75mm from a floor slab above or an adjacent wall. And again, those are structural requirements. So unless we know more about the fire barrier, those are the deemed to satisfy figures that you would stick to.
Okay, I've got Afroz has just confirmed he's comfortable. Sorry, Vance, did you want to say something?
Can I just add to that? But by the way, as a manufacturer, if we want to test a fire damper with less than 200mm between the next penetration, we're allowed to do so now within the standard. So from that point of view, it is a little bit up to the manufacturer. The testing authorities prefer to stick to that rule, obviously, because that sits within the roadmap for testing, being AS 1530.4.
Okay, I've got one from Michael Sadek here. What is the degree of insulation for the MSFD, a motorized smoke fire damper, I'm assuming, to conclude what is the main difference between a fire damper and a smoke damper?
Okay. Well, historically, it's always been the mode of actuation. So a fire damper would have a thermal link, really, that would engage the fire damper. So in the case of a mechanical fire damper, you've got a fusible link that melts and the fire damper shuts. And an intermission damper, for example, once the material gets up to 180 degrees, it expands and the damper shuts. So these are thermal actuators, for want of a better term. A smoke damper has always had to have been actuated from another source, i.e. it's received a signal from somewhere else in the building, and then it will mechanically close. Generally these days it will close on a spring return actuator. That's the most common way of doing it. Our older dampers used to shut on a spring within the damper itself. In terms of leakage, they're both tested to the same leakage criteria. However, a smoke damper is tested in a sprinkler controlled building for a period of 30 minutes. Well, that's what it needs to pass, at a stable temperature of 200 degrees C, whereas a fire damper follows the time temperature curve and we get over 1,000 degrees in testing a fire damper. So hopefully that answers your question. In terms of insulation, there isn't an insulation requirement for a smoke damper. There is for a fire damper.
Okay, so that was that was the other question. All right. So just on that, on the smoke damper. Now, can you expand on that? The difference between the function of a smoke damper and the function of a smoke spill damper, just to clarify between people that there are differences.
Okay, so generally a smoke damper is stopping the passage of smoke across it or through a smoke barrier. So effectively, it's a damper that closes and will not allow smoke or air to pass through within a specified leakage criteria. And that's 100 litres per second per square metre of damper for a damper over 0.5 of a square metre, and it's 50 litres per second per square metre of damper for a damper under 0.5 metres square. A smoke spill damper works obviously to spill smoke, often to clear smoke in a situation. So generally it's closed and it will open under a smoke signal. Not always. If you were to look at a smoke extract shaft, for example, you might find that some smoke spill dampers will be shut, and then on the fire affected floor you might find that the smoke spill damper is open, for example. Right. However, there is a difference in the performance requirement. So a smoke damper has a performance requirement to maintain its integrity for a period of 30 minutes at 200 degrees C for a sprinkler controlled building, 300 degrees C for a non-sprinkler controlled building. A smoke spill damper has a requirement to maintain its integrity or its operational integrity for a period of 2 hours at 200 degrees C and 300 degrees C. And when I say it's operational integrity, both dampers need to be open after that period. So when we test the smoke damper, you would have seen the graphic earlier on of the smoke damper in the smoke wall. At the end of that test period, we had to open the damper. Actually, in our case, I had the actuator open the damper. I wanted to see whether it would actually open. Interestingly, what I didn't cover earlier on is that damper actuators are required to perform identically to a smoke damper. So in fact, you'll find that the damper actuator must withstand 200 degrees Celsius. And currently in Australia, you cannot buy a damper actuator that is rated to 200 degrees C. The closest one to it is a Siemens product. I think it's rated at about 181, I think was the temperature it's rated to. And the only way to effectively do that is to put the damper motor into an enclosure, an insulated enclosure, which again is not often done. The other thing that is important to note from a smoke damper point of view, particularly when it comes to actuators, that the travel time in either direction shall not be greater than 30 seconds. And that's absolutely critical. It does pay to check that. You'll find that some of the spring return actuators in the market today take longer than that to open and shut, and some of them don't. So again, it's worth specifying the right type of actuator on the smoke damper. In our case, in the small circular fire smoke dampers that we've got, we supply the actuators and we wouldn't accept anything else on the damper from that point of view. Does that answer your question, Peter?
Does it answer my question? I think it answers mine. Whether it answers the person who asked the question, I'm not 100% sure, but I'd like him to come back and just confirm everything's good. The next question, thanks again, Vance. The next question is from Amit. It's more regarding maintenance, and I'm not quite sure of his question, but how does a fire damper relate to AS 1851, which I think it's 1851 is reasonably clear on the maintenance, but so I'm not 100% sure, Amit, what the question is. Do we need to test based on the detection system and HVA system, or what standard required to understand to do it? So, Amit, it's a little bit confusing, but I think Vance may be able to comment on a fire damper, which is in 1851, and so is a smoke damper in 1851. But I'll hand over to you, Vance, and see if you can do a general comment, and then if Amit can come back to expand on your question, that'd be good. Amit?
Actually, Amit, there are some requirements for testing the entire system in AS 1851. You'll find them in the start of section 13. And I'm not, I can't remember, unfortunately, the beginning of that standard as well as I can AS 1682 and AS 1668. In terms of testing the fire dampers and smoke dampers, it's very, very clear. Well done, Peter. And AS 1851, the requirements, I think most people know them. 20% of the dampers per year need to be tested. AS 1851 currently requires you to remove or to replace, sorry, all of the fusible links on fire dampers after a 25-year period. We've never really understood why, because they still perform. Intermission dampers, one has to be taken out and tested after a 25-year period to ensure that it operates as it was supposed to. There are some requirements for testing smoke dampers, some quarterly, 6 monthly and annual requirements, as there are with air dampers. Actually, the one thing I would add is any damper that changes state on a fire or smoke signal is considered to be part of the smoke system and falls under those maintenance requirements in AS 1851. So that might be a damper that isn't a smoke damper, for example. That might be a damper that shuts on a signal or opens on a signal somewhere else further down the track. In fact, in some cases, we've seen AS 1851 requires you to clear debris in front of smoke extract louvers and so forth. I've seen closable louvers used as dampers in smoke extract systems, and they then fell under the requirements of smoke spill and smoke extract dampers. So it's important to get that definition right. If you want to email me with a specific requirement, hopefully I can answer that question in a bit more detail and with something that's a bit more concise.
Okay, we've got another question here. Thanks again, Vance. I think, Amit, that should answer your question. If you have a good look at 1851, section 13, and if you have any other questions, by all means, either email Vance. My details aren't on the system, but I'm happy to respond to you if required. But email them to Vance initially, but he has my contact details. Just in case he gets overloaded with emails. The next question, again, there's no name on this one. What would be the installation detail for a fire damper that needs to be installed in an external wall? So I would assume this is AFROS, and it's a carry-on question. Was it AFROS? It's a carry-on question about the external wall. It may have been Ramin. It's just coming up as anonymous, but it's what would the detail be for installation of a fire damper in an external wall? And I think it's a good question, because certain distances from boundaries and all sorts of things come into play with the BCA or NCC.
Yes, they do.
A fire damper is going to have to comply with those. So the detail is something that's not black and white in any standard at this stage. So.
Yes, it is actually. It's very clear at all. What I'm doing at the moment is I'm just about to open a detail. I don't share this sort of stuff very often, but this is sort of out there in the marketplace. I don't know if I can share that screen, but I have a duct to grill detail I'm just going to share a screen for a minute there, Peter, if I can.
Yeah, go for it.
So this is straight out of the our assessment, our short form assessment report. You'll see that detail there that I'm circling. I've highlighted now in the blue. All right. So that is the detail that we would recommend in that sort of situation. So you've got your grill or your louver on the outside there. We actually have an aluminium extrusion that covers the fixing angle. That angle is reversed, right? So that the mounting sleeve for the fire damper doesn't actually protrude out where I've got my little hand in the drawing there. And then the fire damper sleeve goes through the wall. You can see the damper there, our locating springs, because we don't wrap our fire dampers with any sort of barrier anymore. That's the intermission seal. And then there's the mounting angle on the right-hand side there where I've got the arrow round, and you can see the duct going off that way. There would be a requirement to put a duct on that. Although I have, I'll just stop sharing that for a minute, but I have actually helped people in the past to put a wire cage over the back, and just through a lot of the testing that I've done, that there are some, there's good evidence to assume that we lose heat very, very quickly from the fire damper. If you were to look at that graphic that I had up earlier on in the PowerPoint, there we go. Sorry, I'll just find it again. In our PowerPoint presentation, if I just share that one and pop that one over there and share that screen again, that fire damper in that graphic there, you can see that's a 2.4 by 2.4 meter fire damper. Now the fire damper blades themselves are absolutely glowing red, but you see the sleeve on the outside isn't glowing red at all. I can promise you it was over 1,000 degrees behind that fire damper. It was incredibly hot in front of it. We were 2 meters away, and it was unbelievably hot in front of that fire damper. But the air moves so quickly around the outside sleeve that we lose heat in that fire damper very, very quickly, extremely quickly, in fact. And as you can see in that graphic, the outside of that sleeve isn't glowing red at all, right? So from that point of view, there is certainly a train of thought that in our operation, that if you had a wire mesh screen over the outside, that would form a reasonable barrier of insulation across the fire damper, and it would certainly stop products of combustion. And I have had fire engineers accept that solution in the past, where you absolutely cannot put that 2 meter length of duct on the back of the fire damper in that situation. So hopefully that answers your question.
All right. Again, if it's not answered the question, if you could come back with your name as well, so and just refer to the question so that we can make sure we qualify it, or we'll get back to you after the presentation. The next question is again from Amit. It's probably a good question, whether it's directly something, I mean, I would think Vance will be able to answer this, is more a 1670, 1668 question. Do we need any monitoring system for a fire damper? Now, I think the fire damper question is quite straightforward, but a smoke damper or a smoke spill damper can be another minefield. So it'd be nice for Vance to answer that for all three if possible.
Yeah, absolutely. Look, in the situation where we've got a fire damper in that, that shuts, particularly a mechanical fire damper, generally you'll know about it straight away because you've got an increase in duct pressure or you've got resistance in the duct somewhere along the line. If it's a large system with BMS control, it's going to flag an alarm pretty quickly when a mechanical fire damper shuts. If it's a smaller system, there's potential to stall fans and those sorts of things. So I would say generally for a fire damper, it's not really a necessity for just a mechanical fire damper. for a fire smoke damper, you might find that it is worth understanding what's happening in that situation. But if you think about how a fire smoke damper will work, often a fire smoke damper, the smoke damper will shut straight away because we want to deal with potential for smoke coming down the system that's actually quite cold, because smoke loses its temperature very quickly away from a fire. So you could still have the potential for fire coming down that duct and a temperature increase, but you want to make sure that smoke doesn't pass from one side to the other. So you'll shut the smoke damper. But in actual fact, if the temperature got over 200 degrees, particularly with our aluminium one, or certainly over 500 degrees, you start to find that the integrity of that damper it isn't there the same as what it would be for the steel fire damper behind it. Now, bearing in mind the steel fire damper with its fusible link will close at 71 degrees, and its leakage criteria is the same as the smoke damper in reality. And as the damper expands, you know, the leakage gets less and less. With our particular dampers, we've got a flexible stainless steel seal on the side of the curtains, so they seal very, very well when they're cold. Incidentally, normally we cover this because I talk about fire dampers a bit more, but fire dampers leak the most when they first drop and the temperature is cold. When they start to expand more, you find that their leakage does drop, unless the blades buckle or the case buckles, and you get some distortion at that point. But there is definitely a case, I think, for having monitoring on a fire smoke damper in that sort of situation. With just a smoke damper, we can get very, very good feedback from actuators these days. So we used to put micro switches and all sorts of things in dampers to let you know whether they were open or shut. But the feedback you get from actuators now, certainly the ones that we tend to put on dampers, is very, very good. And I think it is worth definitely understanding whether a smoke spill or a smoke damper is shut or open. I think it's quite critical. In fact, I think as our knowledge in this area grows worldwide, I think there'll be more of a focus on smoke than there will on fire. In the course that we run here, I don't know if you've been to it, Peter. I think you might have been to one of our demonstrations here, but one of the things that we do is we show people how quickly that smoke can get out of control. And certainly I run a video that came out of the British Research Institute on a fire that takes less than 3 minutes, and the entire room's black in about 90 seconds. So ultimately, I think that smoke is a larger problem than fire, and I think that as we move into the future, we'll find that there'll be more monitoring and more smoke control in buildings than there is now, even.
Okay, just on that monitoring, I'm unsure whether Amit's looking at whether it needs to be monitored at the fire indicator panel. So that's possibly the question, but a fire damper obviously not. But
for smoke spill, you'll find that it generally does have to be monitored at the fire panel, because often that's something that the fire department will be operating in the event of a fire in a building, and they'll need to understand what dampers are open and what dampers are shut with the smoke management system in the building.
Yeah, what you find is in southern states, you find that's more common than in say Queensland,
That's right. Yeah.
And I think different engineers are interpreting it differently. I've got my own opinion, and I'll keep that to myself for now. But the benefits of monitoring, whether at the fire panel or as a BMS, is that if you try and do a matrix or a full interface test, again, we're back to maintenance.
Yeah.
That if you're, as an example, probably the most common use of smoke dampers is in a hospital or that application.
Yeah.
And you don't want to be climbing up and down in ceilings and things like that. So once you've done the test and you're comfortable with the monitoring, there would be a way of using that for the benefit and the speed of the test without compromising the system. And it is other benefits to monitoring, either through the BMS or preferably through the fire system, because I've got my own opinion, and I believe certainly smoke spill dampers should be monitored. I do not like them switched to the fire panel because quite often you've got fans with multiple damper positions that can cause other issues if you just control a fan or just control a smoke spill damper.
Yeah, I'd agree with you, Peter. I think certainly that the fire department's getting more interested in working more closely with building owners, and I think almost we need to be in a situation with large commercial construction where the local fire department actually understands the management of the building in fire mode and is regularly training people so that if the building does catch fire, people actually know what to do rather than having to try and work it out in the moment, as it were.
Look, smoke management is it's an evolving science in a lot of ways, and the more complicated the building, the more complicated the system, and down the track, it makes it very hard for people to maintain the building once documentation gets misplaced or lost. So,
yeah, well,
right. Questions? Are we right for time, Jen? No comment.
Yeah, look, we're okay to keep going. We've
Okay.
lost a few attendees, but there's still quite a lot of people online. So people
Well, there's about 3 more questions, and they're all a little different. So, again, I've got no name on this one, but it says, are there any requirements for an access point of view away from the fire damper for testing, etc., that could be in a ceiling void, for example, 200 by 200 access hatch times the amount away from the fire damper? I think it's all about the accessibility, and are there any specific requirements?
Not really. It's something that we cover in our design and installation course here at Holyoake. So I try and advise people that maintenance people don't have arms that are 3 meters long, and it's certainly something that needs to be taken into consideration. I don't think that there's a maintenance company in Australia that hasn't had to cut access panels in for fire dampers. So it's certainly something that needs to be understood in design. I think you need to understand the fire damper you're dealing with as well. So, for example, AS 1851 allows you to use camera equipment to view an intermission damper from a maintenance point of view. They still have to be looked at within a 5-year period, the same as a mechanical fire damper does, or 20% per year. We've got a damper, for example, that you can test and reset with one hand. In fact, we regularly do that in the class. So you don't need a 600 square access panel to get into the damper and test it and reset it. So I think it's important to understand the design philosophy of the building, the type of product that's being used, and then it's really up to the designer to make sure that the access points are correct. But no, there's nothing in the standard that would give you a rule of thumb if the fire damper is 150 square, you need to be within 400 millimeters of the damper itself.
Okay, thanks again, Vance. I think that answers that question. There's a couple more here. Fire-rated ceiling, is there any other way than putting an intumescent grill, well, I think intumescent damper, I believe, in the ductwork? I think you've got an answer to that one as well.
In the ductwork?
So I think the intent is a fire-rated ceiling. Is there any other way other than putting an intumescent?
Oh yes, yeah, there is. Yeah, there is. I mean, you can roll the edge of the ceiling up through the penetration and install an ordinary horizontal mechanical fire damper in that situation. I'm not a big fan of intermission dampers. I've got to say, I never have been. I've been around for a little while now, and right around the world. I might add, I've worked in Europe, in the States, Australia, New Zealand, and I've never ever put intermission dampers into a building, because I've never successfully seen one closed other than in a testing environment. So I'm probably not a big advocate of them in that situation. However, what I would say is you're always better to have a damper rather than no damper, and I'd certainly rather see an intermission damper in a penetration than no damper at all. But we have a solution for a mechanical damper with a wooden floor above, wooden floor joists, and a drywall ceiling below. And we have actually tested that at CIBSE, and there's been a number of those installed into warehouses, primarily in New Zealand, where a lot of older industrial type spaces are now being turned into apartment blocks. So yes, there is, but you do need to ensure that the drywall that you've got on the bottom of the ceiling rolls right up through the penetration, the ceiling penetration, that is. So hopefully that answers your question.
Okay, we've only got one more question, but I've got a couple I might just throw in. But we'll ask Kelvin's question first.
Yeah.
If a damper is required to be installed in a subduct of the lobby relief, which is part of the stair pressurization system, is that required to be a smoke damper?
If a damper is required to, right. Well, any damper, I'm assuming the damper in the subduct is so that you can shut that area off.
No, it's to open its primary focus is to open that floor. Okay, so it's open the damper in this, so you allow that floor to be exhausted, quite often used in zone pressurization systems, or so in other words, you've got a subduct that acts as your fire damper. Yeah. And then the damper, its primary role, but its secondary role is to close so that it is not the floor.
The subduct doesn't work yet. Yep. I've seen this a lot in Melbourne, and the answer is generally it has to be a high temperature rated damper as well in that situation. So it depends on the designer, but most of the projects that we've been involved with that have used that sort of technology, we've tended to put motorized steel dampers in that situation. And the leakage requirement is based on the designer of the building. Now, this is where it gets really complex, and I think you'll find under Section J, you tend to want, well, Section J sits outside smoke extract, doesn't it? But certainly you'd want a damper that has the best integrity possible in that situation. You'll find that it's generally a temperature rated damper of some sort. I've got some consulting engineers that want a damper rated to 1,000 degrees in that situation, and we've got other consulting engineers that are quite happy to see a damper that's rated to 200 degrees in that situation. So it really depends on the environment, but yes, you'll find that the damper and the subduct will have some sort of temperature rating, and it's nominated by the designer.
Okay, just on that, just clarifying what we talked about before. So I'll throw it up. If it's 180 degrees, does it comply?
If it's 180 degrees. If the damper's 180 degrees, well, you couldn't put a smoke damper if it's 180 degrees. That's the first thing.
In other words, it's still got to comply with the 1530 test and part 7. Part 7,
yeah,
exactly. All right.
That's right.
Okay. All right, going back to installation of dampers for contractors when they come to inspect. You could argue it's maintenance, but also when they're first installed. So if we're talking whether it's a fire damper or a smoke damper or a smoke spill damper, all have got ratings and temperature ratings. So how would that contractor know, looking at a damper, that it is one of those, not just an air control damper?
Well,
be able to certify it from an initial installation and from a ongoing maintenance point of view.
Okay, so so there should be a log on the site. That's the first thing, and I know there isn't always, but certainly in a recently completed building in Queensland, you should see a log. We tend to find that that's pretty good. Secondly, all dampers are required to have manufacturer's labels on them. And that is an actual requirement. We actually have on the label, we've got to specify what test or what the damper is certified to. So, i.e., our fire dampers have a label within the fire damper case, so it's on the inside of the fire damper, and that'll have the AS 1530.4 test logo on there. It'll have the model number on there. It'll have the manufacturer's details on there, and that's a requirement. So all manufacturers have to fit into that requirement. Smoke dampers are the same. We have to have a label on a smoke damper as well. So every smoke damper that comes out also comes out with that label that's actually embedded in the air side of the damper, right? So it's relatively easy to see inside the ductwork. Assuming you can get to the right side of the damper, because we tend to only put one label on the damper. The other thing is the installer really should have a label on the outside of the duct as well. So all of our fire dampers come with a tear-off label. I think I had a picture of one of those in the slideshow, and we actually provide that free of charge for the installer. In fact, I don't know. Is my screen still shared?
No, it's not been shared for a while, Vance.
Okay, so I'll just share that again. Hopefully we can see that little label.
Yeah,
that label there on the right hand side. So you'll see that little red label. That's an installer's label, and they're provided so that can be fixed. Either to the ductwork or to the wall penetration next to the damper, so that each damper is uniquely identified. Now, that's actually a requirement, that each damper is uniquely identified within the building as well. So you've got a number of ways of doing it. You should be able to see it through the damper list, and that'll come with all of the data within the building. You should see the installer's label either on the wall or on the duct next to either the fire damper, smoke damper, or combined fire smoke damper. And if those two systems both fail, if you look inside the fire damper, you'll see the manufacturer's label on there. And all of us manufacturers are required to put those labels on the dampers.
So it's inside a fire damper. So if the damper's in the duct, obviously you need an access panel to see that. Yeah. So that's not always visible. If it's a 200 by 200 duct, you're not going to be able to get your head in. So you're going to have to use a miniature camera or something. So what about smoke dampers? And smoke spill dampers? Are they usually on the air side as well?
Yeah, smoke dampers they are. We always put them on the inside, so that they're easy to see. And we generally try and put them halfway up the wall, the left-hand side of the damper, if you were looking at it face on. So they're relatively easy to spot. So,
but if there's no access panel for a smoke damper, how do they see the?
You'd have to see it with a camera, but again, there should be a log on site. You should be able to see it with the building data, and there should also be a label on either the wall or the duct adjacent to the damper.
Okay, all right. Let's see if there's any other. There's no other questions coming in. There's still 19 people online. If anybody's got another question, we probably need to start to wrap up in the next 5 minutes. How are you going, Jen?
Yeah, let's start to wrap up.
All right.
Have you got any more questions, Peter?
I'll throw another one. There's a common trend now for smoke and fire dampers combined. We've mentioned it a couple of times today.
Yeah.
How can that be used in a smoke exhaust mode and a smoke spill mode when it's got a fire damper and a smoke damper, not necessarily a smoke spill damper? and if it's used in smoke spill, obviously it's got a fail safe to open, but you've got a fire damper in line.
Yeah, that's right.
And if it's acting as a fire damper or a smoke damper, it has to fail safe to closed.
Yeah, that's right.
Exhaust mode, obviously that's an issue.
Yeah, it is an issue. We tend to find in that situation that people will use what we would call a mini subduct in that situation, and they won't have a fire damper at all. Generally in smoke spill situations. The other way around it, which we have done in the past, is we've put higher temperature rated fusible links on the fire dampers, which we can do. And that is sometimes a way around it, but it's still not going to solve a situation if there's a fire right next to the fire damper on the floor. Generally, look, it's really difficult to comment about that sort of installation and isolation because you really need to understand the fire management system for the entire building. You know, some buildings that's a problem. Some of the smaller buildings that isn't a problem. In that sort of situation, and it really depends on, I think, on the height of the building. You know, if we were talking, you know, floor 46, for example, in that sort of situation, sometimes, you know, if we've got floor 46 on fire and the rest of the building isn't, in a high-rise situation like that, the unfortunate way of looking at this, and certainly it's what I'm seeing coming out of the States these days, is that you'd sacrifice that floor at the to ensure that the rest of the building was safe. So you would shut down that floor and let the fire burn out on the floor and the rest of the building. But it really does depend on the height of the building, the situation, and the overall fire management plan. And it sounds like I'm sidestepping here, Peter. I'm really trying not to, but you know, the fire damper is only a very small part of the picture, as is the smoke damper.
Yeah, look, I think it's becoming, as systems and fire alternate designs come in, people are looking for space in buildings. They don't want to put subducts in. The systems get more and more complex, and the critical thing is the people who are designing them fully understand the limitations of their design, because we want a simple design that's reliable. And I think if we're not careful, if we don't understand the difference between a smoke damper, a smoke spill damper, a smoke damper and an air control damper, then we have a problem. And there seems to be a confusion that I'm finding out in the industry, and things like today is certainly giving a lot of the 30 or 40 participants that attended some good information. So
just on that note, Peter, I can help a little bit. Just one final thing. We tend to find in that situation that a designer would specify a damper with a high fusion temperature. So we don't call it a fire damper from the point of view that it doesn't have a fusible link system on it. So it won't shut independently of any other system on site. But you could take the little LR damper that we've got, for example, the circular one. Now that is a fire smoke damper, and it's also been tested as a smoke damper. So we've got test data that states that it will withstand, you know, 1,000 degrees for a 4-hour period, for example, in a masonry wall. If we put that damper in as a smoke damper, it's exactly the same damper, but without the fusible link, and we're able to call it a smoke damper. I think the real problem here comes in terminology. We don't want to call that a fire damper. What we want to call that is a high temperature rated smoke damper that will withstand or has a temperature of fusion of X, right? And that's the important way to specify it. What you're really looking for is a smoke damper with a temperature of fusion of 1,000 degrees, right? And a leakage rate of, you know, whatever's going to suit your project. The second you call that a fire damper, you've got a problem on your hands. You've got a whole different set of regulations you need to comply with, and a whole different set of circumstances that make the operation of a building in that situation untenable.
Okay, just before I hand back to Jen, Jen and Vance, look, the last question was purely and simply to, could the participants please have copies of the presentation? Is that possible?
Absolutely, yeah. Yeah, absolutely. I'll, Jen, I can send that in PDF form to you.
Yeah, that's perfect. Thank you.
Terrific. Thanks very much, Vance.
Thank you.
Okay. Thank you, Vance.
Jen.
Thank you for that, Vance. That was great. Yeah, as I said, the presentation has been recorded and will be made available online. And just before we go, our next CIBSE Queensland presentation is on the 22nd of September, and that's on mitigating the risks associated with commercial kitchen exhaust systems. So more fire stuff as well as some air treatment stuff as well. So hopefully see everybody there.
Thank
Okay.
you.
Thank you.
Thanks, everybody.